Good afternoon, everyone, and welcome to ERA's webinar on tips to support microbiological proficiency testing. My name is Mike Blades. I'm a product line manager here at Environmental Resource Associates. My responsibilities are in the areas of organics and microbiology. Before we get rolling on today's webinar, I'm going to tell you a few things about ERA. ERA was founded in 1977. Our facility is currently located in Golden, Colorado. We do business with more than 7,000 laboratories around the world in more than 80 countries. In our current location, we have about 25,000 square feet of space solely dedicated to the manufacturing and the laboratory work that we perform. ERA produces a wide range of products in a variety of matrices. We produce products for wastewater, for drinking water, for soils, for air and emissions, for microbiology, and for radiochemistry. We also produce a wide variety of custom standards. All of that work is done under a number of accreditations that ERA currently holds. They're covered under our ISO Guide 34 accreditation, which is targeted specifically to the creation and manufacture of CRMs. They're also covered by our ISO 17043, which is our accreditation that is targeted specifically at being a PT provider and conducting interlaboratory studies. We also have our ISO 17025 accreditation, which covers the competency of testing and calibration laboratories. And then we're also an ISO 9001 accredited facility, which covers our quality management systems. Now, before I get started today with our agenda, I wanted to do just a basic introduction. The intent of this presentation is really to share with all of you some of the experience that ERA has gained over the years when working with customers that have had issues specifically with microbiology PT testing. In general, ERA believes that the keys to acceptable results when it comes to good performance on PTs is first to have a clear understanding of the required sample designs that are placed on all providers and an understanding of how the providers are required to evaluate those samples. Obviously, it requires a good execution of the methods by the participants, and also it's helpful if you avoid some of the basic issues that we've seen over the years that have resulted in participants getting unacceptable results. So with the agenda today, we're going to go over drinking water microbiology, and we're going to specifically cover the presence-absence sample, the heterotrophic plate count sample, the quantitative drinking water coliform sample. And under each of those, we're going to go over the design and the evaluation criteria. We're going to bring up some of the participants' common errors, and then we're going to give you some tips for success. We'll do the exact same thing on the wastewater side when it comes to the quantitative coliforms and the enterococci. We'll go over the design that all the PT providers are required to follow, the evaluation criteria, common errors that we see from some of the participants, and then tips for success. We'll also go over available resources from ERA to help you to be more successful. And then at the end, we'll leave some room for questions. Assuming that we'll have some time, you'll be able to type those into the chat window, and we'll be able to view those, and we'll get to them at the end of the presentation. If in the event I don't have time to get to them, what I'll do is we have a log of all of those questions. We'll go through and we'll answer them, and we'll post them to the website, or we'll respond back to you directly. So I also wanted to make sure that it was clear that these tips that we're going to give you, they're not intended to be an all-inclusive list. There's some common things that we see, but obviously it's not within the time frame that we have here possible for us to cover every error that we've ever seen. Okay, so let's get on with the rest of the presentation. Start with the presence-absence microsample, the required sample design and evaluation criteria. This is information that's all presented on the drinking water FOPT tables and is the basic guideline that all the PT providers have to follow to design their samples to. And it's on the drinking water FOPT table. So it has to be a set of 10 samples. It needs to be composed of anywhere from 2 to 4 E. coli, 2 to 4 Enterobacter species, 1 to 2 Pseudomonas or other species, and 1 to 2 containing no microorganism. So they need to stay within those parameters and create a sample. It also states on the table if you're doing multiple methods within a particular study, the participant must have a unique set of samples for each of the methods that they're seeking accreditation. Now, participants can report presence or absence for each specific analyte. So total fecal and E. coli are all listed on the table for each of those 10 samples. Each specific result will be evaluated individually for each of those 3 parameters as acceptable or not acceptable. And then you're given an overall evaluation, which acceptable is considered to be 9 out of 10 with no false negatives. And you can be evaluated for the 10 total results, the 10 fecal results, and the 10 E. coli results all independently. So you're being evaluated on multiple levels. The table also specifically tells you, or does not tell you, the concentration range for these sample designs. So there is no guidance given to the PT providers as to how concentrated or how dilute those samples may be, and also there is no proficiency testing reporting limit listed on the table. It's considered to be just a presence-absent sample. No quantitative information is actually described for the providers. All right, what are some common errors that we see on this particular sample design? Let me qualify. When I say common error, the errors are in fact not very common at all. It's going to vary by the reported analyte, total fecal or E. coli, and it's going to vary by the organism that's being used, whether it's the E. coli or the Enterobacter or the Pseudomonas or any other microorganism that may be used. Generally, the range or the failure rate, the range of failure rates is going to be from 0.1 to 2.3%. So something like the blank that we'll put in the sample, you may see a failure 1 out of 1,000 times. Whereas with the actual positive controls, the E. coli or the Enterobacter, within a given study, you may see up to as high as 2.3% of your participants reporting an unacceptable result. So, common errors. Labeling or reporting issues when analyzing multiple series. Poor quality of media or inhibitory effects of the equipment producing false negatives. Using the buffer bottles as test vessels and misinterpreting results. False positives on fecal for Enterobacter cloacae using standard methods 9221. Reporting analytes that are not appropriate for the given method. Not following normal procedure when analyzing the PTs, skipping steps. Those are some of the common errors that we'll see. So what are some tips for success? When it comes to, if you're running the multiple series, you just simply need to keep them straight. You need to review bench work to confirm the sets were labeled and recorded correctly. When entering or reporting the results, you need to have some type of a second review on the entry. ERA's website gives you a great function where when you enter your results, it will send you an email as kind of a confirmation of the results that you've entered. It would be a good idea to be taking a look at that and just confirming that you didn't switch anything around. On these particular errors, we've seen them occur at the bench level where the analyst will fill out the wrong data reporting sheet, or we've seen it where that information is passed off to the QA officer, and they enter the results online and they switch the results. So we've seen it occur at a variety of different levels. So you really just need to be careful. There's no way for ERA to make any kind of corrections on your results. What you report is what you report. Another tip for success: perform all appropriate quality control on the method, the media, prior to running the samples. Now, as many of you are aware, there are a number of CRMs that are available for microbiology, not only from ERA, but from a variety of companies. They come at various quantitative levels. They're appropriate for a whole host of methods. With those CRMs available, you should be evaluating media, filters, pads, funnels, incubators, pretty much everything that may be involved in your particular process. You should be looking for any kind of signs of poor performance or any kind of inhibitory effects well before you actually are running a PT. So you want to make sure that that's happening. Phosphate buffer bottles are not intended to be a substitute for your normal sample bottles. So the phosphate buffer dilution blanks that are provided are intended to be used as or not intended to be used as a sample test vessel. They're designed to reconstitute your lyophilized sample, and then you should use whatever your normal method container would be. Whatever you're used to reading results in, you'd want to make sure that you're using something the same. The buffer bottles are not really, they're kind of opaque. It can be hard telling if you're getting the chromogenic or fluorogenic change. If doing standard methods 9221 and using EC media for the determination of fecal, you want to outgas the media after the media has reached the incubation temperature to avoid any kind of false positives. So standard methods 9221E, EC is incubated at 44.5 to determine the fecal. Occasionally, if that media doesn't get up to the incubation temperature very quickly, or you have dissolved oxygen in that media, there is a possibility that you can see some outgassing that accumulates in your Durham tube, just of the oxygen coming out, or potentially activity of the organism before it actually gets up to the incubation temperature. A lot of manufacturers will, that make that media will actually tell you after it's been in the incubator for an hour or two to go back and to get any gas that's formed out and then place them back in the incubator and continue the test. If the organism is present, the target organism is present, you're going to see that production through the rest of the test. So I would recommend that. Another tip, you must report values for total fecal and E. coli for each analyte that you're seeking accreditation. ERA cannot assume that because you reported fecal positive for a sample that you also intended to report total positive. You may say, well, if it's fecal positive, then of course it's total positive. Unless you're reporting the information, we're not going to be evaluating it, and we're not going to be filling it in for you. So it's just a good thing to keep in mind. Only report analytes appropriate for the method that you're using. If you're using a method that determines total in E. coli, you shouldn't be reporting a result for fecal. Should go without saying, but it frequently will happen. Folks just make an assumption, or they're not really well aware of what particular analytes their methods are determining. Perform all confirmation steps required by a given procedure or method. You don't want to take the chance of getting any type of false positive results or false negatives. You want to perform any kind of confirmation steps that may be required. So do your normal procedure, whatever that happens to be. For enzyme substrate methods, don't forget to add the media. You may be surprised how often that actually is an issue. You need to have some kind of process to confirm the addition, whether it's marking the bottle as you add it, putting the blast pack next to the bottle that you've added it to, some kind of process that you can kind of keep track of what you're adding the media to. You don't want to get to the end of the test and find out you failed, and it's simply the fact that you forgot to add your reagent, test reagent. So follow the instructions provided by the PT provider for the product use and reporting. You may see different instructions from different providers on how they want data reported or how you use the product. Read the instructions before you get going. You don't want to have a failure simply because you didn't follow the instructions that you were provided. Another that people sometimes will overlook is always use a comparator for chromogenic or fluorescence methods when they're available. They're not necessarily available for all methods, but you definitely want to use them if they are. It should be part of your normal test process, and you want to make sure that you know that you've exceeded whatever that threshold is to report a positive result for that particular manufacturer. Okay. Heterotrophic plate count. All the PT providers are required to follow the following design and evaluation criteria. It's a single quantitative sample containing a heterotrophic bacteria in the manufacturing range of 5 to 500 CFU per mil. The analytes on the tables are divided into two technologies. They're methods that determine HPC by membrane filtration or pore plate, and then methods that determine HPC by a most probable number method, technique. The acceptance criteria is logged transformed mean plus or minus 2 standard deviations. The PTRLs that are listed on the FOPT tables are 2 CFU per mil. And again, all of this information is spelled out on the drinking water FOPT tables. So what are some common errors that we see on the heterotrophic plate count sample? Well, first, again, let me qualify what is common for this product. It's going to vary by reported analyte, whether you're reporting HPCs by MF or HPCs by MPN. And the range that we'll generally see within a given study will be a failure rate somewhere in the neighborhood of 5 to as high as 10%. This is probably one sample that has, within microbiology, one of the highest failure rates that we see, simply because of the non-selective nature of the test itself and the incubation period and the temperatures. It tends to produce very tight data. It's not uncommon to see acceptance intervals at 2 standard deviations that are very similar to chemistry. So this can be a very tight sample. So what are some of those errors that we do see? Reporting analyte not appropriate for the method or switching the target analytes or technologies. Not running appropriate dilutions to cover the manufacturing range. Counting errors. Media not at the appropriate temperature prior to pouring your plate, causing generally low bias. Samples not run within 30 minutes after rehydration, potentially can cause either a high bias or a low bias. And then results not reported to the appropriate number of significant figures. Pore plate, spread plate, membrane filtration type methods get evaluated as whole numbers, and MPN methods get evaluated at 3 sig figs. So some tips for success when it comes to the heterotrophic plate count sample. Know which analyte your method determines and report appropriately. It's important that all of the participants understand that the data is going to be evaluated based on the analyte that you report. And you have multiple analytes that you can report in this case. Remember, it's HPC by a pore plate or HPC by MPN. Standard deviations that we see can vary by method. And if the interval is going to be determined by the standard deviation of the data, and you inadvertently report your result under the inappropriate method, then it's possible you may get a failure simply because you weren't careful and reported poor plate with the poor plate data or sim plate with the MPN data. Determine what dilutions you will run based on the manufacturing range. Make sure that the potential results will be a manageable number of organisms to count. You may want to consider running samples in duplicate if you don't already do it per the method. Reason being that essentially this can be a very tight data set. You want to make sure that you're running dilutions that are going to give you plates that give you a reasonable number to count. If you were to simply run a 1 ml dilution and you were counting 500 organisms on a plate, there's a high probability of error when you're doing that count. So you want to run a number of dilutions that's going to give you a reasonable plate. And also duplicates just to make sure that the data that you're generating is consistent across dilutions. Temper the media to 44 degrees C prior to pouring the plate. Periodically, we'll see folks that don't control on that very tightly, and you can shock the organisms, and you will have poor recoveries. So it's very important. It's a step in the method. It's something you need to make sure that you're doing. Be prepared to run the sample within 30 minutes after hydration. Remember, you're dealing with microorganisms. Once you've rehydrated them in the buffer, the organisms are viable, and you need to be aware of that. If you leave them in the buffer, the concentration can change. You generally have 30 minutes to 60 minutes to deal with, so just be prepared that when you rehydrate it, you're ready to perform your test. It's quantitative. You want to make sure that it stays that way, so you need to be performing the test in a timely fashion. Again, perform all appropriate quality control on the method and the media prior to running the samples. CRMs are available for heterotrophic plate count samples out there from a variety of different sources. You need to do evaluation on all new batches of media. If you're doing actually a filtration form of this method, you need to make sure that you're evaluating those. Anything that could result in any type of inhibitory effect, incubators, all of your apparatus. Follow the instructions that are provided by the PT provider, again, for the use of the product and the reporting. Again, instructions may vary from provider to provider. We may change our instructions at some point along the line. Don't assume that there were no changes from the previous study. If anything changes, we'll try to call it out for you, but you should always be reading those instructions, even if you've done these studies dozens of times. You just want to make sure that nothing has changed. It's just a horrible way to get a failure. Simplate unit dose versus multi-dose. This doesn't happen a lot, but we do see it periodically. Those two products have two different tables that you use to determine your final most probable number. You need to make sure that you're using the appropriate table with the appropriate format of the product. Make adjustments for dilutions performed prior to reporting your results. This is a common one. When you're doing dilutions on samples, remember you have to report your results in terms of the units that you're provided. You're reporting back to us in CFU per mil. If you do a 1 mil plate, you're good to go. If you do a half a mil or a tenth of a mil or whatever, you need to make sure that you're adjusting that number and putting it into those final units. Again, we can't make any adjustments on your numbers or assumption or assume that we know what you did. So make sure that you're reporting appropriately. Okay. Drinking water quantitative coliforms. So again, we have a required sample design that's put on all the PT providers as well as evaluation criteria. This is a single quantitative sample. It contains E. coli in the range of 20 to 200 CFUs per 100 mils. There are 3 analytes divided into 2 different categories that are going to be evaluated. You're going to have evaluations for total, fecal, and E. coli, all by membrane filtration. You're going to have evaluations for total, fecal, and E. coli by MPN. So you're going to have 6 different spots that you could report your result. Acceptance criteria is going to be log transformed mean plus or minus 2 standard deviations. The PTRLs are 2 CFU per 100 mils. Again, all of this information is on the FOPT tables, and all the PT providers are required to design and evaluate per this information. So what are some of the common errors? Again, I'm going to quantify it as to what is common. Again, it's going to vary depending on the analyte, total, fecal, or E. coli, whether you're reporting by membrane filtration or most probable number. But generally, it's in the 5 to 8% range. So not very common, but generally within every study, we're going to have, maybe 5 out of 100 that are going to have unacceptable results. So what are some of those common errors? Reporting analyte not appropriate for the method. Switching target analytes or technologies. That was common with the HPCs as well. Not running appropriate dilutions to cover the manufacturing range. Poor quality media or inhibitory effects of equipment or supplies producing false negatives or low bias. Not running the sample within 30 minutes after hydration, potentially high bias, or if you wait too long, low bias. Results not reported to the appropriate number of sig figs. Again, membrane filtration or evaluated as whole numbers. MPN is 3 sig figs. When running multiple tube methods, the number of tubes or wells selected did not necessarily cover the manufacturing range. So some tips to succeed. Again, know which analytes your method determines and report appropriately. These different methods will produce different standard deviations, and the fact that we're grouping the data and evaluating based on those standard deviations, you need to be really sure that you're reporting it within the right data set. Determine what dilutions you will run based on the manufacturing range. Make sure the potential results will be a manageable number of organisms to count, again. And run all the sample provided. With ERA, you've got a 100 ml sample. You should be diluting that in a variety of different dilutions to cover the range, and you should use all of the sample through the course of those dilutions. Essentially, you don't want to leave any information unrun, so to speak. Be prepared to run the sample within 30 minutes after hydration. Perform all appropriate quality control on the method and the media prior to running the samples. Again, you've got reference materials that are available out there. You should be using them and evaluating everything about your method before you actually put it into place running a PT. Evaluate new batches of media that are showing up, filters, pads, funnels, incubation temperatures. All of those things should be evaluated to figure out whether or not it could cause any type of poor performance or inhibitory effects. Use reference materials to try to get all of that under control before you're running PTs. Again, follow the instructions provided by the PT providers. It could vary from provider to provider or study to study. It may give you new information related to reporting that was different from the previous event. You want to make sure that you're reading all of that before you actually run the samples. And then once again, make adjustments for your dilutions. You need to report your results in the terms that are on the data reporting sheet or on the website that the PT provider is asking you to report them in. So in this case, CFU per 100 mils. Okay, so the last 2 samples are on the wastewater side. They're the Quantitative Coliforms and the Heterococci that are designed on the, or that are given to you on the wastewater FOPT tables. And I'm going to kind of lump those together because they're the type of errors that we see, again, are pretty similar. and the tips for success are similar. So let's go over the design criteria first for the coliforms. So it's a single quantitative sample. Again, it's going to contain E. coli in the manufacturing range of 20 to 2400 CFU per 100 mils. There will be 3 analytes divided into 2 different technologies. So you're going to have total fecal and E. coli by membrane filtration, and then again total fecal and E. coli by most probable number. So you've got 6 possible blanks that you can report your result on for this particular sample design. The acceptance criteria is again going to be log transform mean, but in this case, since it's a wastewater, it's 3 standard deviations. The PTRLs are set at 2 CFU per 100 mils. On the Heterococci, we'll cover the design on that right away as well. It is a single sample with Enterococcus faecalis in the manufacturing range of 20 to 1,000 CFU per 100 mils. On the tables here, there is only a single analyte, Enterococci, but you can report your results as membrane filtration or as most probable number. The acceptance criteria again is log transform mean plus or minus 3 standard deviations. The PTRLs are 2 CFU per 100 mils. And again, all this information is located on the wastewater FOPT tables. So what are some of the common errors? Once again, I'll kind of describe when I say common what I mean. For the coliforms, it's going to vary from analyte to analyte, total fecal E. coli, whether it's membrane filtration or most probable number. But generally speaking, failures fall within the 2 to 5% range for the coliforms. For the Enterococci, you're going to see, again, it varied by the technology, but generally in the 3 to 6% range. So the failures aren't huge, but they're fairly consistent. And the errors that we see people make, once again, are also fairly consistent. Reporting analytes not for the appropriate method, switching target analytes or the technologies. Not running the appropriate dilutions to cover the manufacturing range. Poor quality media or inhibitory effects of the equipment or supplies, producing false negatives or low bias. Samples, again, not run within 30 minutes after it's rehydrated, causing a high or low bias. And results not reported to the appropriate number of significant figures. Membrane filtration is whole number, and the MPN is 3 sig figs. For clarification on the whole number or for the significant figures, you can report however many figures you think is appropriate for the method. We really just call this out so you're aware of what ERA will evaluate to. When we calculate our limits, we're going to round them to the whole number or to 3 significant figures. If you report more sig figs, you don't report a whole number, you're not going to fail. It's just if you're on the line, it's possible you could be evaluated to the 3 sig figs and fail, whereas if you'd have reported it as a whole number, you would have passed. So that's the only reason that's being called out. When running multiple tube methods, the number of tubes selected did not cover the manufacturing range. So again, on these quantitative samples, some of the tips for success are fairly redundant, but it's what happens and what you need to do to be successful. Know which analyte your method determines and report appropriately. Again, if you mix your data into a different data set and it produces a different standard deviation, maybe a tighter standard deviation, you could fail. An ERA doesn't necessarily know exactly whether your method was wrong or the result or where you entered it. We can try to get it clarified with you, but you need to be very careful because kind of the responsibility is on you for how you report your results. Determine what dilutions will be run based on the manufacturing range. Again, make sure that you're going to create a plate or a filter that's going to be a manageable number of organisms for you to count based on the method that you're running. And you want to run all the sample provided. So do a dilution across that will cover the entire range and will consume all of the sample. 1 mil, 2 mil dilution, 5 mil, 10 mil, 25 mil, 50 mil. If you run all of those dilutions, you're going to give yourself enough information to report a result that covers the entire manufacturing range pretty much every time. Again, run the sample within the appropriate amount of time for ERA sample. It's a 30-minute period after you rehydrate the pellet that you have to run it. Otherwise, you run into the risk of getting some bias into your result just simply because you're not following that instruction. Again, perform all the quality control on the method and the media prior to running the samples. Follow the instructions provided by the PT provider for product use and reporting. Make any adjustments for the dilution performed prior to reporting the results. You're given the units that you're expected to report the result in. Make sure that that's in fact what you're doing. Okay, so some available resources. On ERA's website, we have links to the latest NELAC FOPT tables. If you want to take a look at those and see how the actual criteria is described and the acceptance criteria. We also on the website have a number of different webinars that cover a variety of topics, one of which is microbiology, and there are several posted out there right now that go from basic microbiology, cover issues like indicator organisms or various quality control issues. You may want to check those out. It'll give you a lot more specific information beyond what we've given you here today. Also, ERA has certified reference materials for all of these methods that will come with acceptance criteria based around historical data from previous studies that have been run and the actual studies that those lots went through that you can use as a great reference to try to do the evaluation on all of your procedures, whether it be media or method or filters or funnels or any of those things that you need to make sure that they're not having any inhibitory effects. You can get products from ERA that can help you accomplish that. There are other FAQs, frequently asked questions, out on the website that you could take a look at that if there were issues that I didn't cover related to reporting or use of product, you can find answers out there on ERA's website as well. We also have copies of the instructions that are located out on the website that will have helpful hints for the known samples. So you might find that a useful resource. Also, ERA has individuals here that have experience running all of these methods that will spend as much time as needed with you to try to work through any issues that you may run into, any questions that you have about the products. Please call ERA. The technical support is here for you to use as part of our service, and we would really like to make sure that you're getting the right answer on the studies and your QC samples, and it's very helpful. You should take advantage of it. Okay, now as I promised, let's take a look at some questions. And bear with me here, we are trying to read things through a chat window here. Sorry about this. We have a very small chat window. It looks like there's a question from Gail. Will you ever be able to provide whole volume ready-to-use standards like other companies offer? ERA actually did manufacture whole volume samples years ago when we first started to provide PT studies. There are a lot of issues related to whole volume samples that, at least at this point, ERA has kind of been steering clear. It has to do with trying to make those samples actual certified reference materials and meeting all of the criteria of, making them actually certified. They last for a very short period of time. They need to be shipped on ice. They need to be run very quickly after they're received. I clearly understand the convenience of the sample, but we have kind of some questions when it comes to using those as actual reference material. The other issue is once you create one for a given study, it really is only good for a very short period of time. It can't really be used if someone were to have a failure in a study. They can't go back to that sample because it doesn't exist anymore. So I can never say that we never will make a whole volume available again in the future, but we'll have to see. We don't think it's an ideal way to provide a microbe product. Okay, we have a question from Carol. Will you provide a copy of this PowerPoint to attendees? Yes, we're actually recording this whole webinar, which will have all of the audio as well as all of the actual screens from the presentation. It'll get posted out on the website and will be available for everyone. I can't tell you exactly how quickly it will happen, but it's generally, maybe later this week we should be able to get it out there. Okay. We have a question from Grace. Will this be on the DMR QA study? Not sure I understand the question exactly. I mean, these samples, the wastewater coliforms, is part of the DMR QA study. So it is applicable to that study, and the acceptance criteria also applies to that study. We have a question for Salam. Which method, enzyme substrate or membrane filtration, is more accurate? Which has more failure rate? I don't know that I have a definitive that I'd be comfortable answering that. They're both approved methods. The accuracy of them, it depends on which membrane filtration method you're talking about. The less selective medias produce more consistent results with some of the enzyme substrate methods. If you go to the methods that are a more restrictive media or temperature, they in fact can produce a more skewed result between those. So I'd say, if you're comparing M-endo with Quantitray, I would say they're far more consistent and their accuracy is similar. Hopefully that answers your question. We got a question from Mike. What difference should you expect between fecal and E. coli at temperatures of 44.5 C in fecal and 35 degrees C E. coli? Differences as far as results. The more restrictive the method is, you're going to see lower counts. So restrictive in the nature of an incubation temperature that is further from optimal. So E. coli's optimal growth temperature is down around 37 degrees C. It'll grow at 44.5, but you wouldn't expect to see the same recovery between those two temperatures. Also, media plays a part. If it's a more selective media, you're going to see results biased more towards the low side. So you're going to see a difference. The more restrictive the method, either temperature or selectivity in the media, the more skewed the number you're going to see towards the low side. I mean, all micro methods have a tendency to produce more low results than they do high results. It's just the nature of the microanalysis. So adding selectivity to the media or the temperature is only going to enhance that. Okay, we've got a question from Patricia. When entering results on the web, where you choose the method is a bit obscure, any hope of making data entry screens clear? Yes. I think anytime you have any kind of feedback on any issues that you're having with the website, on ease of use or clarity, bring it to the attention of the PT group, or I will pass that information along to them. You can bring it to the attention of the tech folks. We definitely will take a look at that and try to improve the usage on it. We have another question here from Yoon. Let me see. Oh, I'm sorry, Ellen. Since different methods have different standard deviations, why combine the methods together to evaluate instead of evaluating them individually? If I wasn't clear on that, they are evaluated individually. Each of the different products that I described, they split the analytes out by both membrane filtration and the actual target analyte. So total coliforms, fecal coliforms, and E. coli by membrane filtration are all looked at individually. Total fecal and E. coli by MPN are all looked at individually. So you would have 6 different data sets in that scenario. So they are in fact split out for the various reasons that you point out, different standard deviations. Okay, we've got one from Yoon. It was, we're having low bias results for ColorSure Quantitray. Any ideas or tips that may help us deal with this low bias? That is an issue that we've seen over the years with a variety of different strains of E. coli and formats of product. Not all of these different methods perform identically. They're going to have different levels of sensitivity. There is no real good way that I can tell you to improve the sensitivity of a given method. I can just tell you that, in fact, there are differences. Run quality control, make sure that the lot of the particular product that you're using is performing as well as the previous lot that you had. Make sure that any other variables in the methods that you're making sure that none of those things are contributing to that low bias. But I don't have a good recommendation for that. We've just seen it have a low bias. People are generally passing, but it tends to be grouped on the lower end of the results. We have a question from Grace on, is the enterococci on the DMR QA study for wastewater? Currently, there is no requirement under DMR QA to run a proficiency testing sample. There may be some specific state requirements that are asking you to run that, but currently the enterococci is not included as a core target analyte on the study, just a wastewater coliform sample. Okay, it looks like we got a lot of other questions out there. But what I'll do is I'll get a printout of all of the questions, and I will try to go through and answer those and post them on the website. I'd like to thank you all for your time, and that basically concludes today's webinar. Thank you very much. I hope that you found it useful.